Alrighty, welcome to our second to last lecture. My name is Kanu. I am your TA that'll be leading this lecture on data visualizations, specifically Seaborn and Matplotlib. Okay, before we get started, let me just import a few useful tools for us. So let me just go over a couple of these in case you guys don't know what these are. So Seaborn is one of the data visualization tools that I'll be using today. Seaborn and Matplotlib are the two, I would say, most useful data visualization tools that we're going to import here. Um, and then CSV is just to load in my file, and then I will import NumPy as NP and Pandas as PD, and throughout the code we'll be referencing all of these. And I also imported a few things right here. This is just to make our data look nice. It's not really used for any functional purpose. It's just so the graphs that we plot um, look a little bit better and a little bit more understandable to us. And the last thing I imported was my data set. And today, the data set that we'll be looking at is a Kaggle database of movie box office revenue predictions. So basically, once I load the data, you'll see, but it's basically a table of a bunch of different features of a particular movie and then its corresponding revenue. And today, what we're going to do is we're going to use data visualizations to find which variables in this data set are most strongly correlated to an increase in movie revenue. So we'll take a look at that in just a few moments. But before we get there, let me just talk about something that's really important that we're going to be needing for today's lecture, and that is data visualization, the data visualization tree. It basically talks about all the data types our data can take. So if we scroll down here to this little graph, this picture, these are the data types that we have in general. So our two main types of data are categorical data and numerical data. And I'm sure a lot of you guys know what this is, but I just want to review it in a little bit more detail, and it'll make our life with visualization so much easier. So the two types of data types I told you are categorical and numerical. Categorical talks about a particular category of data. It gives data somewhat of a description, and you're dealing with descriptions or variables that can be observed, and you can't generally draw any like linear correlation with a categorical data just because it's mainly data that's in the form of a description, if that makes sense. And our second data type is numerical data. This one's a little bit more straightforward. Numerical data or quantitative data is data that deals with numbers, strictly numbers, and this can be measured in like numerical units. So there's this type of data a lot of the time is used to determine linear correlation, something that categorical data cannot be used for. But under these two types of data, we have a little bit more specifics that I want you guys to know because this is really important in today's lecture. But under categorical data, we have two different types of data, nominal and ordinal. So nominal variables or nominal data is something that you can think of that has no quantitative value, and that's completely unordered. So changing the order of nominal data really has no difference in our data set. So say we had a, an example of nominal data can include gender, for example, gender male or female. It's data, but it's not quantitative, and it's not in any particular order. It can be male female or female male. Another example is blood type, zip code. Zip code can be thought of as a quantitative variable, but usually we use zip code to represent the description of a location. So it's important to be able to make that difference when it comes to categorical and numerical data. And our second type of categorical data is ordinal data. And ordinal data, or ordinal variables, is a little bit similar to nominal variables, but the major difference in this case is that ordinal follows a specific order. And you can think of that as ordinal order and nominal no order. So not ordinal data includes things like socioeconomic status, like wealthy, middle class, like that follows a particular order, or a better example, education level, like preschool, elementary, middle school, um, and then high school, college, graduate, like that follows a particular level. So those are the two types of data in uh, categorical data. And then numerical data, we have interval data and ratio data, which can be thought of continuous and discrete. So continuous variables, as their name implies, are variables that take on a continuous number of values. So for example, we can consider height continuous data because height can be anything from 0 to like whatever 500, but it can include values like 180 and a half pounds. It can take any value along that given interval. And discrete data can only take on fixed values. And what I mean by that is like we can think of it as the number of dollar bills in my piggy bank. I only have so many dollar bills. I can't have half a dollar bill. So that's the important distinction. So ultimately, all of our data types, we have categorical, which includes nominal data and ordinal data. And then we have numerical data, which includes continuous variables and discrete variables. So this data visualization tree, as I like to call it, is going to be really important in helping us find out which visualizations we want to use for which types of problems that we have. Okay, so in general, data visualization is really important in determining relationships between variables. There's a lot of different things, as you guys know, line plots, histograms, box plots, some of the things that we'll be covering today. And each type of data visualization is used for its own type of data, if that makes sense. And it's really important because using these different visualizations, we're going to need to be able to analyze the variables that we have, and we're going to eventually have to determine some type of correlation using these visualizations. And what we learned today is really key to understanding relationships between variables and ultimately how these relationships allow us to build models like machine learning models, which you guys will cover if you choose to take more advanced data science classes. But so what I want to do right now is I want to import our database. Our database again is the movies table. So let's just do that real quick. So I'll just run movies. Okay, so this is our database. It has, let's see, 3,000 rows. It's a pretty big database. And this database has features of movies, such as if the movie belongs to a collection, the budget that movie was given, the movie genres, um, the original movie or the original language of the movie, the title, an overview of the movie, its popularity, release date, runtime, all kind of stuff. And then on the very last column, we have revenue, which is going to be our most important column here. And the reason I wanted to go over this is because each type of column has data that exhibit different types of um, data types in our data visualization trees. So for example, budget, right? Budget we can think of as a continuous numerical data type because again, it can take on any given value, uh, just like a dollar amount. Because budget is a dollar amount, we can have any specific amount of money in our budget. So that's going to be really important as we look at our visualizations to categorize these into their different data types. So yeah, so that's our movies database. Now, I want you guys. Okay, so the idea of today's lecture is that we're going to use data visualizations, specifically Seaborn and Matplotlib, which I brought up over here. We're going to use those two libraries to figure out which variables are the most exhibit the most or exhibit a strong correlation to movie revenue, which is in our last column. So amongst all of these variables, these columns, excluding revenue, which one of these show a strong relationship to revenue? Meaning, if I have more of a budget, will I have a larger revenue? If my title is, or if my movie belongs to some collection, will I have an increased revenue? If my movie has a specific runtime, if it's longer than usual movies on average, will it have a higher revenue? And all these questions are going to be really important to consider. So I want you guys to pause this video and I want you guys to think which variable or which variables do you think will be most strongly correlated to an increase in revenue. Amongst all these different columns here, take a few moments to think about which variables you think are the most critical to determining an increase in revenue. So I'll give you, um, so yeah, just pause this video and uh, write your, I guess, educated guesses down. And don't try to inspect our data because, again, we have over 3,000 columns. So using an educated guess, maybe from the first few rows, I want you guys to determine what you think, um, what you guys think this will be. So pause the video. All right. Okay. I hope you guys have your answers, and we'll get started. Cool. So let's just take a look at the first. This is a pretty big data set, so let's just take a look at the first um, 5 columns of our table. So to do that, as you guys learned, we're going to be calling movies.head, and that'll give us the first 5 rows. Sorry, not columns. First 5 rows of our table. So we have all these different columns. Okay. And so if you guys look at these columns, a lot of the the, the data type that we receive from Kaggle is a little bit off sort. We have like, if you can see here, we have like dictionaries contained within lists. It gets really confusing. We have some null values over here. We have the links. We have all this type of stuff. Um, we have a lot of weird types of data that we really can't analyze with any function in Python because Python will only take a specific data type. If you pass in, like for example, if you pass in this crew value with a dictionary of different crew members, you know, Python's not going to be able to read that just because it's in a really whack type of format. So before we get started with our visualizations, I actually took a few moments to write some code that'll help us uh, extract what we really need from this data set, what the most important features are, what the most important columns are, because some of this stuff is really redundant and we need to cut this down. So I'm just going to copy over some code I wrote in a different notebook, and we can uh, talk about what exactly I did to this data set. Okay, so cool. All right, so we have these are so this is what is called feature engineering. Feature engineering is basically um, a process to cut down our database into its most useful components and to get it into the data types that we want. So let me now call, now that I ran these two by pressing Shift Enter, let me now call the data set once again. We're going to call this, our new data set is going to be called revised movies. So let's just take a look at the first 5 columns of this. Okay, cool. So if you guys can see, there's a major difference between what we had up here and what we have down here. Our data is a lot more simplified. So what exactly did we do? Okay, so let's look at our first column, belongs to collection. So this this variable is basically telling us, does this particular movie belong to a series of movies? So for an example, I can give you like Harry Potter, right? Harry Potter belongs to a larger collection of movies. So in this column, for the movie Harry Potter, we're gonna see that it'll give us a really weird data value that basically tells us that yes, this movie does belong to a collection. But if you think about it, because we're only trying to find the relationship between a particular variable, in this case, and a movie, so for this variable specifically, we're not going to need to know what exact collection this movie belongs to. We're just going to want to know that it either belongs to a collection or it doesn't. So in this case, if you see that we have a value represented in this column, then we can safely assume that this movie does in fact belong to a collection. And if you take a look, if we have a NaN value or a null value, if we go back to our original database, we can safely assume that a null column or null row basically tells us that we don't have a particular series associated with this movie. So what I did basically in our revised table to make it more easier to conduct our visualizations, I basically just put yes or no. Whether it belongs to a series, I put yes. If it doesn't, I put no. The budget column I left the exact same because that was pretty good. Um, Genres, okay, so this column right here, I cut it down into, I took out the lists, sorry, the dictionary within our list, and I just took out all this redundant information right here, like the ID, this name, just so we have the different genres in our movies. So, like for example, our first movie is gonna have just comedy. Our second one's gonna have these four different genres. So I just made that a little bit easier in our code over here. So I took out a few columns that aren't going to be necessary for us, like this IMDb ID or this homepage. Again, like links are really redundant. We're not going to be able to conduct any data visualizations for like a link, or an ID that has really no meaning for the movie. So I took out a few of those columns. Original language, that was a perfect variable. That's a pretty good variable actually in determining revenue. If a movie was spoken in English, it'd have a higher revenue than a movie that was spoken in Chinese, for example. So that's going to be a pretty big column for us. The title of the movie isn't really useful for us because again, all these movies have different titles. But for the sake of this data set, I did decide to include it in our. Actually, I did not. So okay, just kidding. Yeah. So movie title has no meaning. We're not going to be able to classify movies by their title, obviously, because each row has its own unique title. Overview, again, this column is pretty redundant. We're not going to need to know this. Um, has no statistical meaning for us. Popularity, if you recognize from our data visualization tree, this is actually a continuous numerical variable. So this one's going to be pretty important for us. So I kept this column. Release date is also a really important column because depending on the date, and maybe not the specific date, but what I did was I extracted the year of release and the month of release. So in our new data set, I added a column called release month and release year. That's basically the month a movie was released and the year it was released. That you can see that these do in fact match up. So we're gonna do some statistical analysis to see, maybe if a in a more recent year, do movies generate more revenues, and that's gonna be really important for us. Runtime is also a great indicator as it's a numerical value. Spoken languages, I decided to take this out of my data set because I thought that original language would be enough, just because a lot of these do match up between what's spoken and the original language. So I took this out. Status I took out as well. That's not really important for us in determining revenue. I took out the tagline. I took out the title. Um, I took out these keywords. Again, these are all data types that aren't going to be useful for us. I took out the cast too because obviously every movie has a different cast, and we're not going to really see any casts, match up unless maybe it's part of a series. But again, we already have a variable for that, so that's not going to be very important for us. And then our last variable was crew. This again is not really important, but the revenue column I did include for obvious reasons. That's what we're going to be finding a relationship to. So we're ultimately determining in our cut down data set how many of these columns that I decided to include in my data set, how many of these columns or which of these columns have a correlation to the revenue of a movie, which is now in this column right here. So again, this was just an introductory video to our data set, just so you guys understand a little bit about what we're working with here. Essentially, how it's all the movies in this data set that also includes 3,000 rows. So we didn't take any data out. It's 3,000 different movies, all with different variables. We're going to see which of these variables for these movies does revenue have a pretty strong correlation with. So now we'll move on to our next video in just a moment.